Hi students, today we'll be discussing on what are some of the factors that can actually affect the rate of dissolving in a solution. So for today, what we'll be talking about is focusing on three factors, namely temperature, surface area of the solute, and the stirring action, the rate of stirring, in influencing the rate of dissolving. Now this is very different from the previous factors that could actually affect solubility of a solute in a solvent. That would really depend on the nature of the solute and also the nature of the solvent in terms of solubility. So let's begin. So in terms of so let's start off with a form of imagination. We try to visualize. Every morning when you want to have make maybe a cup of Milo or to drink something, to make a cup of Milo, which would you prefer? Which do you think will actually dissolve the Milo powder even faster? Is it a cup of hot water or using a cup of cold water? And then of course you stir. What you will see is that when you pour the Milo powder into a cup of hot water and you stir, right, it's a lot easier to stir, it's a lot faster to stir. To dissolve. However, as you compare to maybe you use cold water and then you use the same rate of stirring, okay, you realize that the Milo powder doesn't really dissolve as fast as the one in the hot water. So why? Why is this actually happening? Okay, so there is it's actually due to this concept of energy, and which in other case it's a kinetic energy. So what is kinetic energy? Kinetic energy, right? Okay, kinetic energy is actually can also be considered as energy that contributes to movement. So in this case, right, how is then influenced by how does this actually temperature, how does it actually help to improve the change in kinetic energy? So as the higher the temperature of the substance, this will actually lead to an increase in or higher increase in kinetic energy, while a lower temperature will result in a decrease in kinetic energy. So these are some of the items that can actually affect. And of course, how does then the kinetic energy helps to improve or allows us the substance to actually dissolve faster? In a way, what happens is when you stir, right, the particles within the powder itself is able to vibrate faster, and this helps to actually allow it to overcome the intermolecular forces of attraction holding the particles itself, so that it's able to become smaller and smaller, and hence it's easier to actually dissolve. So that is the main that's one of the ideas behind why when you stir in hot water it generally is able to dissolve faster. Now in the next, we look at this particular condition. Okay, so just now it's talking about temperature, as you can see. So this is mainly for temperature difference. For this particular experiment, cup 3 and cup 4, you realize the particles here are of different sizes. So if I were to bring this up, this concept is mainly for the one over here. Okay. So you may want to pause the video to copy this down into your notes. Okay, and of course these slides, right, are reference from Star Publishing Private Limited. Please get the textbook. It's really very good, and in a sense it's going to help you to complement your learning. These videos are not here to replace your textbook. You will still need your textbook, so please purchase them and let's start studying. So next is, okay, so in this case, right, we look at the size. You could see that the difference is in the size area of the coffee bean. Okay. One is very small size surface area, small size, and the other is large. Now there is a difference between size and surface area. So surface area of exposure is basically the smaller it is, you have a larger surface area. So having a smaller size, you have a larger surface area. So in terms of when you write your answer, please be very clear. Are you talking about size or are you talking about surface area? So in cup 3, the size is actually very large, but the surface area is low. As compared to the other one where, of course, surface area is with respect to all of the coffee powder inside. So then of course this one is the size, it's small. And the surface area is large. Now, which one will be able to dissolve faster? Of course, it will be cup 4. Now, why cup 4 dissolve faster? It's because of the increased exposure of surface area interacting with the water molecules, the water particles. And when you stir it, right, it will then be able to dissolve even faster as compared to you actually having a smaller surface area. So imagine, like for example, when you hang your clothes, you usually open up wide, big. The surface area of exposure is there. Therefore, when you put it under the sun, it dries faster as compared to you crumping up all the things inside the clothing, and therefore not able to absorb. So it's the same thing. So imagine, right, one coffee bean powder is so big, right? This is just one of it, and inside you got a lot of coffee powder. All the nutrients, all the essence still stored inside it. So what is exposed, right, is just the outer surface area. So even though the particles is big, but if you look at the surface area of exposure inside, it is still very crumped up. It is still, the only things that are exposed is the outer surrounding it is exposed. As compared to, let's say, in cup 4, right, the same exact let's say you have you use the exact same bean, okay, and then what happened is you crush it into smaller pieces, so you remove. Do you see that now the surface area of exposure is a lot more? You can actually, the water can actually interact with even the inside particles also, and this helps to increase the rate of dissolving. So that is, so imagine your clothes, right? You actually let it open, and so the sun is able to shine throughout the whole cloth. Okay, it's the cloth, it's the sun. As compared to over here, you have a crumpled clothes, a cloth, where you are only exposed to the outer one, and the inside structure, which is hidden away from the sun, is not able to be dry out faster. So that's the main relationship between size, surface area, and rate of dissolving. Next, we look at over here is whether you stir versus never stir. So which is actually faster? Definitely stirring is faster, because when you stir, right, you are trying to increase the frequency of the water molecules to interact with the coffee powder. So as you are able to interact with the coffee powder faster, it will be able to dissolve faster as compared to you just leaving it there and leaving it to random chance, okay, moving slower. So imagine yourself when you're running, when someone is behind pushing you to move faster, definitely you will move a lot faster as compared to someone who never push you, never do anything to you, just run at your own pace. So same thing here. Okay, so when you stir, when you increase the rate of stirring, you are also increasing the rate of dissolving. Now do take note that stirring and dissolving, there are two separate actions. Stirring is you taking maybe a spoon and then you rotate it. Dissolving is actually the solid itself, the solute itself, that is actually being broken down into smaller pieces in the water. Okay, you dissolve in a particular solvent. So the rate of dissolving is actually a measure of how fast a solute and dissolve completely in a solvent. So do remember this particular definition, as this is the definition for rate of stirring. So be very careful in exam. Are they asking you for solubility or are they asking you dissolving? They are two separate things. Okay, so in exams you will also be asked as to what are the factors that can actually affect the rate of dissolving, and this could maybe get 1 mark each. Okay, in which you will be, and not only that, but you will also be able to explain how. Okay, like just now how I explained. So in comparison with two different substances, you must be able to explain as well. Okay, so when we look at temperature of a solvent, heating a solution increases the rate of dissolving. Okay, and this is for example, when you use hot water, you dissolve sugar faster than cold water. The reasoning is because of when you have an increase in heat energy, you would actually increase in the kinetic energy. So what happens is your solute move faster. And when your solute moves faster, it will be able to interact with the water faster. In upper sec, we learn it as frequency of effective collision, and this would actually increase the rate of dissolving. Okay, what is increased rate of dissolving? That means you use lesser amount of time to dissolve something. Next, we look at surface area. So you can see down here what they meant. So in the sense for this one, right, cup 4 will be able to dissolve faster. Okay, sorry, just now this one is cup 1 will dissolve faster because it has a higher temperature. For over here, it's the size of the particles. So cup 3 has a lower surface area, and over here it has a higher surface area, and therefore it dissolves faster. So in other words, what happens is, if let's say a large size solute, okay, let me change this. If you have a small size solute, you would actually have a increase or higher surface area. And when you have a higher surface area, okay, the particles are able to interact with your the water much easily, or the solvent used easily, and hence it will actually increase the rate of dissolving. So next we look at rate of stirring. Of course, rate of stirring is over here. Cup 5 will be able to dissolve faster. Now, why is cup 5 able to dissolve faster? Because it has the stirring action, while cup 6 do not have the stirring action. So if you increase rate of stirring, you would increase the rate of dissolving. So this is another example of how it is. The intermediate steps is mainly when you stir it faster, you increase the frequency of effective collision between the solute and the solvent, hence it's able to dissolve a lot faster. But this is not required for your syllabus as of now. You will need to just know that rate of stirring increase will result in an increased rate of dissolving. Okay, so the next video I'll be talking about what are acids and alkalis and how does it actually influence your solutions. Okay, so take the time to revise your work, and good luck for your studies and learning. Okay, I'll see you in the next video. Remember to like the video, subscribe to my channel, and thank you.